In this video, we're going to continue to look at increasing and decreasing functions. So firstly, we're going to have a look at a task on algebraic proof, and for the following expressions in this task, if we were given a value for x in the real numbers, then what values would these be, basically? Would they be positive? Would they be positive or equal to 0, so greater than or equal to 0? Would they be less than 0, so negative, or would they be less than or equal to 0? Now, I'll do the first one with you, and then you can pause the video and have a try at the others, have a wee think about those. So, if we had x in the real numbers, and we have x squared, so firstly, if we take x to be a positive number, x squared would also be positive. If x was 0, then x squared would be 0. And if x was negative, well, x squared, a negative squared, is a positive. So for x being any value in real numbers, then x squared has to be greater than or equal to 0. So at the moment, I would pause the video and have a wee look at the others here and see if you can work out what they would be. Okay, welcome back. So hopefully you've managed this, and if not, don't worry, we're going to go through it anyway. So this one now, we've got x squared plus 9. Well, if we know that x squared is greater than or equal to 0, if we add 9 onto each side of that inequality, then it must mean that x squared plus 9 is greater than or equal to 9. Okay, but actually the inequality that we were asked to use, the inequalities here, it means that x squared plus 9 is going to be positive. So it's always going to be greater than 0. Now, if we've got negative x squared, so that's the same as negative 1 multiplied by x squared. Well, if we know that x squared is greater than or equal to 0, if we multiply that by negative 1, it then would mean that x squared would be less than or equal to 0. If we take an example, if you had a positive number, x is a positive number, you square it, you still get a positive number, you then multiply it by negative 1, you then get a negative. So negative x squared is less than or equal to 0. Now this time if we get negative x squared minus 4, so that then has to be strictly less than 0. If we use from the example above, this would be less than or equal to negative 4. But again, we're using only these inequalities, so this is strictly less than 0. Now, this one here, x minus 5 all squared. Well, we know from above that anything squared has to be greater than or equal to 0, so surely this holds true here as well. So let's try some values. Say x was 6, so we would have 6 minus 5, which is 1, square it, it's still 1, so it's positive. Say we had x being equal to 0, for instance, so x minus 5 is negative 5, 0 minus 5, sorry, is negative 5, square it is positive 25, so it's still a positive number. If x was 5, for instance, 5 minus 5 is 0, 0 squared is 0. So actually this is greater than or equal to 0, and it's similar to the x squared being greater than or equal to 0. Now, the negative of x minus 5 all squared, again similar to negative x squared, is less than or equal to 0. And finally, we've got x squared plus 6x plus 9. Now, that actually is very similar again to this first one and to the x minus 5 all squared, because what we have here is x plus 3 all squared. So that is a perfect square there, and it's greater than or equal to 0. It will always be positive or equal to 0. So this task here will hopefully help us as we move on to look at increasing and decreasing functions. So firstly, looking at increasing functions. If we have a curve with equation y equals f of x, if y increases, so if y gets bigger as x gets bigger, so if y increases as x increases, then the curve is said to be increasing. And when the curve is increasing, tangents will slope upwards, i.e. their gradients are positive. So that means that dy by dx, the derivative, which is also the gradient, is greater than 0. Those might look something like that. So you can see that both of these straight lines here, the tangents, are sloping upwards from left to right. So that means that their gradients are positive. So that's quite important to remember, that increasing functions, dy by dx is greater than 0. Now if we look at decreasing functions, so again if we've got the curve with equation y equals f of x, if y decreases as x increases, so if y gets smaller as x gets bigger, then the curve is said to be decreasing. And when the curve is decreasing, tangents will slope downwards, i.e. they have negative gradients. That means that dy by dx will be less than 0, and we might have diagrams that look like this. And you can see from left to right here that both of these tangent lines, straight lines, are sloping downwards from left to right. So what I've highlighted here in purple, put the box around the dy by dx greater than 0 for increasing functions and dy by dx less than 0 for decreasing functions. Those are quite important. Now, if we look at increasing and decreasing functions together then, so I've put a picture of a curve on here, and you can hopefully see that there are areas where it's increasing and areas where it's decreasing. So you can see here up to this turning point here that the curve is increasing, and that means that dy by dx is greater than 0, so the gradient is greater than 0. Now between the two turning points, you can hopefully see that the curve is decreasing, so dy by dx is less than 0. And finally, from this turning point, which is on the axis, dy by dx is greater than 0 because the curve is increasing again. So it's important to look at graphs and see what the behaviour is. That will help us later on. So what's happening between the turning points, and that will prove to be quite useful just now and later on in the higher course. So let's look at some examples. So example 1. Show that the function f of x equals x cubed minus 3x squared plus 3x minus 10 is never decreasing. Now, our solution here, I firstly want to look at the language here. If it's never decreasing, that must mean that the curve is always increasing. So it's always good to get a sense firstly, right, is it always increasing or always decreasing? What is the behaviour here? So just understanding the language is really important. Now, before we look at any algebra, I'm just going to show you the graph here of this curve. And you can see that it's always increasing. So from left to right, it just appears to keep going up. And that means that the gradient has to be greater than 0, i.e. f dashed of x is greater than 0. So we've got our expression for f of x, and if we differentiate that, we're going to get 3x squared minus 6x plus 3. Now, I need to show that this is going to be greater than 0, no matter what value of x this function takes. Basically, at any point, what is the gradient of the tangent to the curve at that point? So given any x value, it needs to be positive. So we'll firstly take out a common factor. So we've got 3 bracket x squared minus 2x plus 1. And then if we look inside that bracket, actually I can factorise that further. That is a perfect square, so it's 3 bracket x minus 1 all squared. Now, you can see there from earlier, if we have a square, we know that it's greater than or equal to 0. So we looked at that in the first task in this video. And then if we multiply that by 3, well, we're multiplying it by a positive, so the answer's still going to be positive, or equal to 0, of course. So that means that f dashed of x is always greater than or equal to 0, therefore f is never decreasing, i.e. it's always increasing because it's greater than or equal to 0. And again, I'll refer you back to the graph. You can see that there. You can see it's always increasing. It's never decreasing. It's never going down. So just now would be a good time to pause the video and take this example down in your notes. Okay, welcome back. So, a second example. Show that the curve with equation y equals 5 minus 4x minus x cubed is always decreasing. So obviously in the last example we looked at one where it was always increasing. We needed the gradient to be greater than 0, and this time we're looking at one where it's always decreasing. So we know that the gradient needs to be less than 0. So let's just start again by looking at the curve, picture of it. And you can see here it's always decreasing. So we'll start y equals 5 minus 4x minus x cubed. We need to differentiate that. So that gives us 0 from the 5, minus 4, minus 3x squared. Now, we can't factorise that expression. We can't actually do anything further with that. So we need to look at what's happening here. Now we know that x squared on its own is always greater than or equal to 0. If we multiply that by negative 3, well, that then means it's going to be less than or equal to 0. And then if we subtract 4 from that, it means it's going to be strictly less than 0. So we can see there that dy by dx is less than 0. Therefore, f is always decreasing, which is what we were looking to prove. And again, you can see that from the graph. There's never a point on here where the tangent would be increasing, so we can see that there as well. So just now would be a good time to pause the video before the screen goes blank.